Let's talk about how climate change will impact plants. One of the major factors of climate change that will affect plants is rising temperatures. Global warming will 1. Spread pathogen conditions northward, and 2. Increase the duration of favorable pathogen conditions. A 1950s study states that the range of temperature between 45 and 80 degrees Fahrenheit is when pathogens are able to reproduce most successfully. And since places with colder average temperatures will have periods of time with more moderate conditions, these pathogen conditions will spread northward to areas that otherwise would not have had these moderate temperatures. In addition to having longer periods of pathogen activity, rising temperatures can lead to pathogens infecting plants even earlier than usual, as areas with harsh winters will warm up more quickly. In this case, moisture refers to the amount of water vapor present in the air, and it is predicted that climate change will cause dangerous increases in humidity. A moist environment makes a glorious world for pathogens. Some climate change models predict that more extreme precipitation events will lead to longer periods of time with favorable pathogen conditions. Basically, more frequent and longer rains will lead to more frequent and longer periods of time with moist conditions. For example, fungi that spread the disease powdery mildew heavily favor and are most efficient in warm, moist conditions. Another result of increasing moisture is that plants become more susceptible to diseases. Some disease spreading can be linked to leaf wetness, humidity, and precipitation measurements. Some insects, such as the apple scab, late blight, and a variety of vegetable root pathogens, are more likely to affect moister plants, making the increase of moisture in our environment even more concerning. At first, rising carbon dioxide concentration for plants may not seem like an issue. After all, it is food for plants. However, even the increased growth of plant biomass can lead to more favorable pathogen conditions. Plants grown with increased CO2 concentrations have been shown to develop denser canopies with higher humidity, which, as discussed, favors pathogens. Additionally, plants decompose at a slower rate with conditions with higher CO2 concentrations. This could increase the crop residue on which pathogens can overwinter, resulting in higher pathogen presence at the beginning of the growing season, as well as earlier and faster disease epidemics. The idea of overwintering, coupled with the fact that winters may become even shorter, shows how all three of these effects work in conjunction to increase the spread of plant diseases. We've discussed that a changing climate will lead to more favorable pathogen conditions. But let's go into detail about how exactly it helps them. Insects are cold-blooded organisms. This means that their body temperature is about the same as that of their environment, making temperature one of the most important factors that impact insect lives, making climate change lead to a variety of effects on insect populations. Increasing temperatures will lead to two major things for insects. 1. More species of insects, and 2. Larger populations of insects. Temperatures becoming warmer across the board will affect insects' life cycles, since they are so reliant on temperatures to determine their behavior. For example, insects reproduce more actively when temperatures are warmer, resulting in more generations per year. Since temperature essentially determines insect behavior, some insects may be able to pass through more vulnerable life cycles more quickly. An overall longer lifespan of insects, as well as an increase of reproduction, will cause more generations of insects to be present at once. As discussed previously, favorable pathogen conditions will also be expanding northward. Insects that migrate may end up in northern regions earlier, spreading whatever diseases they may carry much quicker than anticipated. Insects also move with the crop that they infect, and since climate change is creating conditions that allow crops to move northward, so too will insects. Things seem stark right now, but there is hope in nature's ability to adapt. Because of a changing environment, plants will evolve to survive in new conditions. Essentially, changing environmental conditions, such as increased CO2 levels and increased temperatures, create conditions that are outside of plants' physiological limits. Plant migration may also not keep up with how rapidly the climate is changing. Because of this, it is predicted that rapid evolution will be how plants respond to a changing climate. Increased plant biomass may cause plants to become more resistant to fungal diseases, as well as allow plants to build up physical resistance to insects. How exactly a changing climate will change plants physically is a complex topic, and not entirely predictable. But a physiological resistance to pathogens could be one of the effects of their rapid evolution. Despite this, the complex matter of plant evolution could also impact them negatively. Even though climate change can result in physiological changes to plants that cause them to become more resistant to pathogens, this may also work in pathogens' favor. For example, more rapid plant evolution may result in a higher chance of pathogens evolving to overcome plant resistance. The efficacy of pesticides might also be negatively affected by changes to plants that make them have slower uptake rates as well. And since pesticides may not be taken up by the plants, more extreme weather conditions brought forth by climate change, such as longer and more frequent periods of precipitation, will make it harder for fungicide and pesticide residues to remain on crops in the first place. Now, how exactly will all these changes to the environment affect farmers? Climate change will have several detrimental impacts on farmers' profits and livelihood. Increased moisture and temperatures will cause pathogen conditions to increase and spread, making farmers have to deal with more varieties and quantities of insects, overall increasing the cost of pesticide treatments. For example, an insect known as the corn flea beetle spreads bacteria that infect corn plants with Stewart's wilt. They have been known to survive more commonly in warmer winters than colder winters, and those more moderate conditions are spreading to areas that otherwise would not have had to worry about them. To combat this, farmers are going to have to use pesticides. However, there are multiple insecticide varieties which often trade off efficacy for taste and texture, and vice versa. So the dilemma farmers might have to face with the increasing frequency of Stewart's wilt and other diseases is whether or not they use more efficient pesticides to combat the increasingly more resistant corn flea beetles, but sacrifice the taste and texture of their crop. Both of these options will likely affect their annual profits, but which method is less detrimental is yet to be determined. What's more is that increasing generations of insects will cause pesticides to be applied more frequently. Generally, insecticides are applied to plants infrequently to prevent insect resistance from spreading. With more applications, the chances that insects evolve resistance will increase. Changes to the climate will negatively impact farmers' profits overall, by forcing them to use less appealing pesticide options, or causing farmers to spend money on pesticides they otherwise would not have had to as a result of favorable pathogen conditions spreading northward. So that brings us to the ultimate question. How can we remain hopeful in spite of this situation? In truth, climate change is a much more complex issue than simply saying that it will just harm plants. For example, although longer and heavier rains might make pesticide residues wash off of plants, these rains might also wash pathogens off of plants and be detrimental to the lives of various insect species. Also, many pathogens are tied to their host crop. Changes to temperature that may cause farmers to decide not to grow the crop anymore could effectively wipe out the pathogen population that was once thriving. As mentioned previously, plants have the potential to build up physical resistance to pathogens as a result of their predicted rapid evolution. If you think about it, all of these different factors that we've discussed can be used to argue for or against pathogen disease spreading, and that is what makes predicting climate change's effect on plants, pathogens, and the environment so difficult. What we can do to remain hopeful is to know that climate change is a gradual process, and that all these changes we've discussed will not happen all at once. What we can hope for is that farmers will have ample time to adapt to the issues they may be faced with in the near future, and that some humane solution is found by that time.